The intention of this video is to demonstrate the importance of training in manual material handling, but it didn't mean that training the workers is the only solution for controlling the musculoskeletal injuries that might be caused by manual material handling. In hierarchy of control, reducing or removing the factors that cause the injuries and implementing all the engineering control strategies to avoid the exposure to those factors have the higher priorities. The training methods are only recommended when all the other control measures cannot be implemented. This video does not prescribe one specific training method, but it definitely shows the weaknesses and advantages of different training techniques that are being trained by professionals and are being suggested in training manuals. Again, it is important to know that the balanced lifting technique proposes that human body is a unique structure and it should be used in a proper manner.
Injuries from the manual handling of loads is as old as human history. Manual material handling is the first solution that comes to our mind. In fact, we all perform some sort of lifting at work, during exercise, at home, or any number of places. Most manufacturing or distribution systems require some manual handling tasks, and while it may be decreasing lately, the rate of workers that carry or move heavy loads is still high, reaching 38%.
Manual material handling entails lifting as well as climbing, pushing, pulling, and twisting, all of which pose the risk of injuries to the shoulders and the back. There's been a lot of research to create methods to prevent or minimize the injuries associated with lifting. Despite using these methods, the rate of musculoskeletal injury is still high, even when the person carefully uses these techniques. We deal with so many patients on a daily basis who claim to use proper lifting techniques, but they don't seem to know how to use their body efficiently, and as a result, they hurt themselves.
Why do these injuries still happen despite people using these methods carefully? Dr. Mohammad Abdoli is a professor of biomechanics at Toronto's Ryerson University. The high rate of injuries during manual handling of loads caught his attention, so he started to investigate the occurrences among workers who use these methods, reviewing training materials, textbooks, online resources, and videos. His findings are interesting.
Reviewing 60 online resources, textbooks, videos, and training materials around the world, I realized that almost all the lifting training programs focus on prevention of spine and shoulder injuries with little emphasis on proper usage of the legs. Their important message is to keep the back straight and to bend the knees. It is interesting to see that there's not enough details on how these joints should be used. Employees learn that they have to bend their knees or they keep their back straight, but how?
Dr. Abdoli's research led him to an important finding.
Almost all of the studies that question the efficiency of the training are based on the existence of training programs in the workplace rather than the specific training techniques that was used in that program. In fact, many systematic reviews that found the training methods ineffective did not identify the techniques that were used for training the workers. On the other hand, most of the biomechanical studies that compare the lifting techniques focus on the lower back rather than all the involved joints such as hips, knees, and ankles in the lifting activity.
Dr. Abdoli also discovered that prioritizing one body segment over another, such as lumbar spine versus knees, causes a constraint on the lower extremities. That would be one of the reasons that many trainees avoid lifting with their legs, because it could be as bad as lifting with the back.
Consider a stoop lifting method, for example. The posture is obviously not recommended in repetitive lifting activities.
But how about the squat lifting activity shown here?
The squat lifting postures seem to put less stress on lumbar spine. Well, interestingly, biomechanical models showed that if the squat is not done properly, the lumbar spine loading is the same. The issue is that during the squat, especially in deep squat lifts, the hips, knees, and the ankles are under more stress.
That raises the question, if you are trained by a lifting program to use your legs in order to handle the load in your workplace, Do you really follow these instructions?
Obviously not.
Maybe this is one of the reasons that lifting training programs around the world are ineffective.
Our team in Occupational Biomechanics, Ergonomics, and Injury Prevention Lab in the School of Occupational and Public Health at Ryerson University is proposing a systematic training program that is called Balanced Lifting Technique, or BLT. The idea behind BLT is to use all the body joints involved in lifting in a balanced way.
Before we describe the BLT method, let's review the most important principles in getting ready for proper lifting. Make sure your body is ready. Like athletes, before lifting, you need to prepare your body by warming it up. A warm-up gradually revs up your cardiovascular system by raising your body temperature and increasing blood flow to your muscles. Warming up may also help reduce muscle soreness and lessen your risk of injury. Make sure that you warm up before any physical activity. Start warming your body from the toes and end with your neck joints, because all of the body segments and joints are involved in the lifting activity. Keep both feet flat. A stable posture is when both feet are flat on the floor. Any posture causing the feet to bend reduces the postural stability. Deep squat is one of the unstable postures, where the feet are bent and there is less contact between the feet and the ground. Kneeling is the other unstable lifting condition. It looks stable at the beginning of the lift, but it gets unstable when one foot is switched from behind. A stable posture could be defined as a posture in which the center of the gravity of the lifting is located at the center of each foot, or at the center of the two combined. To understand this concept, try lifting a light object from the floor while your feet and legs are completely attached to the wall. Normally it is impossible to lift the load in this posture unless the body balances the weight of the load in the other side. Learn how to use the hip joint. Bend the knees and the hip joints together. This section of our training video is very important. Please note that when you lift a load below your knee height, your feet, your legs, your thighs, your pelvis, your spine, your shoulders, your neck, your upper and lower arm, and your hands and fingers are involved. You should use them all in a proper way. Any condition that uses one joint more than others should be avoided. Although using the hip joint sounds too easy, many people have a hard time using the glute and hamstring muscles synchronously, and it takes a while for them to get used to it. Spine posture has been addressed extensively. There is a school of thought, usually biomechanists, believing that the spine should be kept straight in all lifting activities. Another group believes that the spine should be used in curved postures as well to prepare the joints for unexpected circumstances. But in repetitive tasks and for lifting heavy loads beyond 5 pounds, the spine should be kept straight by holding on to your natural lumbar spine curve and contracting the abdominal muscles. Keep the back straight and flex the trunk via the hip joints. When the spine is held straight and the hip joints are used, the lifting range of motion is reduced, and the knees are the best joint to compensate and to provide the required movements. Never twist your spine or other joints during the lift. Lifting should be done symmetrically through all the ankles, knees, hips, lumbar spine, and even shoulders and the neck joints. Twisting about these joints increases the risk of injury significantly. Now that you are familiar with the concept of joint loading in different lifting conditions, let's review the common lifting techniques in the workplace. Stoop lifting. In this lifting posture, the feet and legs are placed in parallel and the knees are kept almost straight. People might curve the spine or keep the spine straight, both of which is not recommended, especially in repetitive tasks and when the load is placed too far from the lumbar spine. The stoop posture is based on whether the trunk is kept closer to or below the horizontal axis, or above from the horizontal axis. As a rule of thumb, any trunk angle beyond 80 degrees could be considered a stoop posture. Full squat or tradition squat lifting. In this method, the knees are fully bent and the feet are kept slightly angled outwards, 0 to 15 degrees. Because the knees are bent and the load is placed in front of the feet to reach the load with the hands, the feet are flexed and the whole body is placed on the two toes with minimum contact with the ground, which gives the least stability in this posture. The trunk is kept close to the vertical axis or flexed up to a 30-degree angle from the vertical axis. It is possible to curve the spine in this posture as well. However, curving the spine is not recommended, especially in repetitive lifting tasks and when the load is very heavy. Semi-squat or athletic lifting. In this method, the knees are flexed to almost 90 degrees. In this posture, athletes recommend to keep the thighs closer to horizontal and the shanks closer to vertical. However, people tend to keep the thighs above the horizontal axis. The feet are still closed and are placed at shoulder width. The load is located in front of the knees and the feet. Again, the spine can be kept curved or straight in this posture. However, it is not recommended to curve the spine in repetitive and heavy lifting activities, especially in this posture because the load is kept too far from the lumbar spine. We draw your attention fully to this posture. The knee in semi-squat or athletic postures should be held almost at the top of the ankle as much as possible. When it is not possible to keep the knees at this point, you should at least avoid passing the knees beyond the tip of the toes. This way, you can use the weight of the body to balance the weight of the load with minimum moments on the ankle joints. As soon as the knees pass the tip of the toes, you put too much effort and stress on the knee muscles. Most of the individuals, especially those who have weaker muscles, avoid this method of lifting. Therefore, it is important that you use the right cue when you train the athletic lifting. Kneeling lift. The kneeling lift method can be split up into two stages. The first stage is when the lifting leg is flexed at 90 degrees and the lower leg is held vertical to the ground. The lifting foot is held flat on the ground, ready to carry the whole body weight when the other leg is flying in the stage 2. The kneeling leg in stage 1 is flexed at 90 degrees but is held against the floor. In this stage, almost 80% of the body weight is on the kneecap. When the load is lifted from the ground, most of the body weight is on the lifting leg. This posture of the body puts asymmetrical loads on the lifting hip, knee, and the ankle in comparison to other types of liftings where both feet are flat on the ground and the lifting is conducted symmetrically. On the other hand, the force being applied to the kneecap makes this lifting method unsuitable for any terrain that is less than ideal, such as wet, rough, or icy terrain. The lifting leg joints, including hip, knee, and ankle, are all undergoing flexion and lateral moments in comparison to the squat lift. The lumbar spine flexion moment in kneeling lift is less than applied flexion moment in all other lifting postures. However, the ankle and the knee flexion moment of the lifting leg in kneeling method is 2 to 3 times larger than the applied moment to the same joints in squat lift. The knee is not designed for lateral movement, and performing the kneeling lift method may cause knee instability. Older workers or workers with compromised knees could be at a higher risk for injury if they perform this lift. Now that you have observed different methods of lifting the same load, let's explain Dr. Abdoli's balanced lifting technique, or BLT, in different lifting postures. In this method, the legs are kept open and the feet are placed around 45 to 60 degrees outward. The idea behind balanced lifting is to open the knees and bring the load closer to the body, almost between the two ankles, while you do not allow the knee joints to bend less than 90 degrees. The spine cannot be curved in balanced lifting technique and should be kept completely straight, while the abdominal muscles are contracted. Similar to semi-squat, The knees should not pass the tip of the toes and have to be kept above the ankle joints as much as possible because of the wider stance. And also, all the body joints are actively engaged in moderation. Larger size loads can be approached from the sides and grabbed with extended arms. When the load is lifted from the floor, it is brought closer to the body. The load is placed back in the reversed sequence. Manual material handling and lifting below the knee height is still unavoidable in spite of the recent technological advancements. Proper lifting technique is very important and should be taken seriously. In order to limit workplace musculoskeletal injuries, workers should be physically and mentally prepared as well as trained to use proper techniques.
For years, scientists and occupational health and safety organizations have advertised for proper lifting techniques by showing pictures and videos. As professionals and researchers, we assume that videos and pictures are considered as training materials, but they are not really. In my opinion, we can't say someone is trained until we make sure that all the involved joints and the related neural networks are trained by a professional in the field for a specific task and for a specific load that the person handles. If group of joints are overused or used improperly, employees avoid them and switch to incorrect techniques. In my opinion, a proper lifting technique is a technique in which the individuals are trained in the field long enough to be able to use the involved joints in a balanced way. What we mean by balanced is the technique that does not overuse one joint over another in repetitive tasks.